Hey everyone, my name is Tony Trung and I am a product marketing manager at Dremio. For our webinar today, we'll be going over DataOps, a new methodology for data lake management. Joining us today, we have Anushka, who is the Director of Product Management at Dremio, and also Kevin Petrie, VP of Research at Eckerson Group. And for the agenda today, we'll kick off by talking about the shifts in the data management architecture. And after that, we'll be going over DataOps, data lakehouse management best practices covering CI/CD, data orchestration, testing, and monitoring. And with that, Kevin, I'll let you kick off the show.
Hey, Tony, thank you very much. Really appreciate the opportunity to speak with folks here and share some perspective based on research we've been doing at Eckerson Group about what's going on in enterprise environments and what the notion of an open lakehouse could offer you, what DataOps as a discipline comprising people, process, and technology can offer as well. I always find it helpful to start a conversation like this by saying, why are we here? What's the problem we're trying to solve? There's no shortage of problems to solve in technology. Data and analytics are no different. This visual here, which I've adapted a little bit from some great Dremio material, really illustrates, I think, this increasing web, this polyglot architecture that a lot of organizations find themselves in. And they do it because they've inadvertently accumulated technical debt in a variety of ways. You have various data stores that you've added to over time, individually, all for the right reasons. You have a lot of different users and applications and tools that you're accumulating as well. And in between them, there's kind of this bloat, this set of one-off arrangements, data copies, tools, a lot of pipelines that are connecting point A to B and C to D and E to Z. And as a result, it can be kind of a thorny mess, something that's pretty hard to govern. Organizations are struggling because they've got a lot of individual requirements without a coherent plan to address them. They've got a number of different data copies that they've derived from what's within a traditional, say, data warehouse in order to meet one-off performance requirements. And they're doing all this to optimize individual workloads for individual business units and user groups. As a result, as you can see here, it's very hard to manage, and I think organizations are looking for ways to get beyond this thorny web that modern data warehousing has become. And so at Eckerson Group, we have a consulting division. We work closely with a lot of Fortune 500 companies and also mid-sized enterprises that are establishing what good might look like from a strategic perspective and a product evaluation perspective. And we've really defined 7 must-have characteristics of a modern data platform, a modern cloud data platform in particular. It's important to unify what you have, unify the way you're presenting data to users, unify the way you're perceiving and retrieving data from various data stores. Another critical piece here, and it's a lot easier said than achieved, is simplicity. The more you can reduce the manual burden that data engineers and data analysts and data scientists have to deal with as they wrangle data and ensure data quality and deliver it to different users, you want to reduce a lot of that work. Accessibility is also critical. The thorny web that I showed earlier is challenging in part because if you have a new set of users who have some very innovative use cases they need to address, they need to make sure that they have broad access to the right data sets, any and all data sets they might need in a timely fashion. Fast. We all need data very quickly. COVID is one of the many things that's hit the fast forward button on digital transformation. And what that means is that so many more business interactions, especially with customers, are accelerating. And what this means from an analytics perspective is that real-time analytics, low latency analytics is critical. So enterprises need to figure out how to get a modern data platform that's going to meet those performance requirements. Economy is critical. The macroeconomic picture is sobering, challenging, a little volatile right now, And it just underscores that organizations need to take a hard look at the cost of cloud compute, at the inefficiencies within their infrastructure. Governance has obviously always been critical. It's equally critical now given recent legislation on both sides of the Atlantic related to handling of personally identifiable information. And the more you can reduce the number of data copies you have, the more you can ensure quality and reduction of risk with how you manage it. Final point here is open. I'm going to talk a little bit about architectures and the pretty rich ecosystem of commercial and open source technology elements that you can put into your architectures. And it's critical that organizations maintain open data formats, open APIs, open access to anything that's out there today and that they might need in the future. So those critical 7 components or requirements are really going to drive the rest of the discussion here. And so the open data lakehouse is a broad concept. There are a lot of different terms getting used in overlapping ways. I view the lakehouse as essentially a cloud data platform that is combining the best of the data warehouse and the best of the data lake, or aiming to do so, because you're looking to consolidate BI workloads and data science workloads on a common platform. You're looking to query multi-structured data objects, and in most cases you're querying semi-structured or structured data, tabular data, and then presenting virtual data views through a unified semantic layer to your clients. And so there's a lot going on in the next slide here. There are a lot of architectural elements at play, and it really underscores the point that I had earlier about the need to maintain open access to your ecosystem. So let's work through this. Let's go from the bottom up. The object store is increasingly the favored way to classify and store data. And so we've got options here from AWS, Azure, and Google in the cloud. Object storage is also gaining traction within the enterprise. Most enterprises are looking at 1 or 2 clouds, and they're looking at a hybrid elements, some on-premises stuff as well. And they're looking for a lakehouse that can straddle those environments and make the best of them. There's this data layer going up from there where you've got file formats, different ways of accessing, of organizing data. And so this might be Parquet, it might be Avro, it might be ORC. There are also table formats. And there are also these meta stores. And I think that Anushka is going to talk in a little more detail about what that entails. But the key point here is that there's a lot of innovation at the data layer, in particular with open source movements such as Project Nessie, which is helping organizations manage data and versions of data like code, and that helps ensure data quality, which we'll be talking about. Working up on this diagram, the next layer is the processing layer. And there are a lot of critical elements here. One of the key ones that I'd point out is apachearrow, which is obviously an Apache open source project. And that's processing data in columns rather than rows, which can accelerate performance and speed access to tabular data. Another aspect of the processing layer that can streamline workloads, accelerate workloads, is caching. If you can proactively prefetch high priority data to cache, then you can really optimize performance when that data is frequently accessed. Pre-computation is another aspect of the processing layer. There will be queries that are executed frequently, and it really helps to think ahead within the processing layer in order to retrieve the data in the organized format to meet those. So I won't go through each of these items here, but these are all potential contributors to a processing layer that is really streamlining workloads. It's accelerating performance so that you can get the performance you need without the cost or complexity that you don't want. This semantic layer is critical. So the semantic layer is going to catalog all the data within your environment and create different virtual views so that you can understand what your options are to assemble, retrieve, and deliver that data in order to meet different query requirements. Data lineage is something that you need in a lot of context. The semantic layer is going to provide that view about where data started and what its provenance is onto the target. Masking can help meet some of the governance requirements because you can obfuscate certain columns of data that'll have PII. And then the client layer obviously has a lot going on in terms of rich tools to interact with data. It's going to do that through a communications layer, a set of open APIs and transfer networks. Apachearrow Flight comes to mind here because this can help reduce the need to serialize and unserialized data as you're accessing it. So all these ways, this is sort of a rich ecosystem of options, an a la carte menu, if you will, to enable the open data lakehouse for organizations that are looking to speed access to their data and meet different requirements. Anushka, why don't I hand over to you?
Perfect, Kevin. That's exactly what customers see when they come to Dremio. It is the easy and open lakehouse platform. So traditionally, customers would put their data into their engine, and you'd bring your data into the engine. It's really hard to move it. You were stuck or locked into leveraging that engine for all your use cases. But the world has evolved. Your data volumes have changed. Tools and use cases specialize the applications and tools for those use cases. So it became really critical to think about this open lakehouse. The cloud data lake and lakehouse flips this model. You now have this open bottom layer, the data tier, as you mentioned, with file formats, open source, table formats, and you bring your engines to the data. So your engines could be Spark for machine learning. It could be a number of streaming engines like Flink. And if you're interested in SQL, we at Dremio pride ourselves on delivering one of the best SQL engines. But all of these engines need to work together on the same set of data and support multiple use cases, whether those are your BI tools and dashboards or ad hoc analysis, or your data scientists, where they're taking data from their data lake and connecting it to data that exists in a lot of their existing enterprise data warehouse or database systems, to basically solve their use cases as the world, as you mentioned, has seen the digital transformation need them to leverage data for decision making. And so this flexibility and choice of an open system is really important when you think about it from a cost perspective, both for today and in the future as you're scaling. And the critical piece is, how do you manage this lakehouse platform? So you get data in, you manage the quality of the data, and you bring in data governance easily. And I think that's where the recent DataOps framework comes into play and really helps us think about this differently. And so for that, it would be great if you could share a bit more about that, Kevin.
Anushka, thank you very much. Really great perspective. And at Eckerson Group, we've done a lot of research, starting with my colleague Wayne, back before it was cool, say in 2018, looking at DataOps, this notion of data operations, which is a set of practices, it's a frameworks, methodologies comprising people and process and technology in order to help organizations make data pipelines more efficient and effective as they deliver timely, accurate data from point A to point B and transform it along the way. What does this mean, and how is it relevant here? We see data operations, data ops, as having 4 pillars. The first one is CICD, the notion of continuous integrating and delivering pipeline code workflows that are going to extract, transform, and deliver data to various targets that need to use them most often for analytics. And so CICD is a set of practices involved in DevOps, and it's applied here because it helps you frequently update and improve pipelines. It's critical here to maintain a single source of truth for code, pipeline code, and also for data. And Anushka will be talking more about that. The second pillar of data ops is orchestration. And this is where we're starting to automate sequences of tasks across applications, across tools, so that you can connect the dots and make sure that as data is getting consumed, as pipelines work together, as pipelines deliver data to applications, either for analytics or operations, that flow is automated. so that you can automate the data journey end to end. That orchestration piece, that automation piece is a critical part of DataOps. The third major pillar here is testing. In order to ensure you have high quality data and high quality pipelines that will deliver timely data, it's critical to check the quality of the data, check the performance of data pipelines, that functionality, both during development and during production. Those tests are critical. Monitoring is a way to contribute to that, and that brings us to the fourth pillar. Monitoring, which I really view as observability, data observability, is going to look at how pipeline code is executing commands, and it's going to look at the performance and the quality of data delivery. DataOps teams need to quickly identify and respond to issues. So DataOps can improve data delivery with CI/CD, orchestration, testing, and monitoring. And when you do this, it can really start to supercharge an implementation of an open data lakehouse. And so let's look at what that means here. If you apply DataOps to the lakehouse, you're able to continuously update, orchestrate, and test all the elements that I was talking about earlier that straddle the data layer, the processing layer, semantic layer, and so forth. So versions of data, processing jobs, semantic models, transformation logic, queries are just some of the elements that need to get along with each other and need to perform at a high level, and they need to have accurate representations of data. It's critical to enable DataOps with a hard look at how you're monitoring all those elements. That's where data observability comes in. Data observability is effectively monitoring for data quality and monitoring for pipeline performance. So DataOps can help enterprises optimize all the various elements of the open data lakehouse. I view it as a critical enabler of this notion of a lakehouse. I want to make one more point here about observability. We've done a lot of research about data observability. As I said, it's the monitoring component of DataOps. And so DataOps can monitor the lakehouse using that data observability. It's going to go through 3 different life cycle stages in order to do that. This entails validating data quality and detecting issues. So you're going to potentially look at using machine learning algorithms, identify patterns, identify anomalies or breaks in the patterns, outlier values, jobs that failed, errors in the data. You need to spot that stuff. And that brings you to the second phase, which is assessing and predicting. You want to triage issues according to their business impact. As an example, you want to measure that impact and then trace the workflows across the sequence of tasks so that you can identify a root cause by correlating different events. Once you isolate that root cause, you want to move to resolution and prevention. This is where you're going to control what's happening in the environment, debug code, optimize infrastructure by tuning it, for example, and cleansing data. So to put this in the bigger perspective, within the lakehouse, you want to keep a close eye on stuff. You want to find issues and fix them in order to improve uptime, improve decision quality, and cost. And so our advice at Eckerson Group is to figure out how to enable timely, effective data delivery within the lakehouse environment and look for architectural elements that are going to support these DataOps scenarios. And so now I'm going to hand over to Anushka, who has some additional thoughts on that.
Thank you, Kevin. I want to talk a bit about DremioArctic. I think Kevin mentioned before something called Project Nessie, which is an open source project that introduces Git-like capabilities for data. DremioArctic is essentially Dremio's managed Nessie service. And so, as Kevin was talking about earlier, the key to having high quality data in your data lake and reacting to new data quickly is being able to easily control versions of data, to isolate your experimentation, your ingest, and to dramatically reduce the cost of error. That means not having to manage multiple copies of data or complicated data pipelines. So with Nessie or DremioArctic, we enable you to manage data as code, bringing Git-like capabilities that you're familiar with in the DevOps and software engineering disciplines to data. So you can think about branches, tags, commits when you're working with tables of data. So what does that mean? That means you can have a simple way to create a development environment. You just create a branch from your production environment. Familiar concept. But this isn't a copy of your data, it's a snapshot of your data lake. And this is possible because of open table formats like apacheiceberg tables or datalake tables. They have the notion of snapshots, which you can think of as point-in-time versions of a table and the data associated with it. So when you create a branch in DremioArctic, you're not copying your data, you're copying pointers to table snapshots. So any inserts, updates, and deletes that you do are basically moving that pointer, and they're completely isolated in that development environment or branch. So your production data and environment retains a consistent view of the data lake. So we've talked to a lot of customers who struggle with isolating errors, just as Kevin talked about. And it's really complicated in a data lake because you're dealing with tons of files. And your ETL pipelines might introduce something that affects your production data. This is really hard to isolate, really hard to fix. So with DremioArctic, customers are excited that they get a safe way to ingest data. They can set up pre-merge hooks to validate that the data is accurate before it is merged or deployed into production. Now, this mimics DevOps capabilities or best practices that enable CI/CD, as Kevin was talking about before. So those are known best practices for deploying new code. Here you can apply those same practices to deploy new data or a new ETL pipeline. And another point that we talked about earlier was isolating errors. Well, with Arctic, if you've introduced an error in your production data, you simply roll back to a previous commit. You revert a commit. And now you've atomically taken your production data back to a good state, and you isolated the commit or all of the transactions that introduced the error. So we've even made it easier for you to debug. So you can focus on just the files that were affected with the commit. Another key component that branches provide that is really critical in a data lake is consistency. So the main branch is your production data, and you want to get a consistent view. So a BI dashboard that's querying your data or a data scientist that's querying your data does not see partial results from an ETL pipeline that's in progress. Well, as the picture shows, if you have an ETL branch where you're ingesting, transforming data, it's done without touching your production data. And you can have your pre-merged hooks test that your data is right before you merge it in. And that merge operation is atomic. So you might have 20 transactions where you inserted, transformed data, but you want to atomically update your production view so that your BI dashboards or other queries always get the latest, most accurate set of data. And that's what you get when you merge it in. So I want to make that a bit more clear through an example. So if you think of it workflows, and you think of a data warehouse, you think of transactions that are often one session or one user running a bunch of SQL statements, and they commit them when they're done. But in the real world, when you're managing data in a data lake, you often involve multiple tools, multiple engines, as we talked about before. You might have Kafka to ingest some data. You might do some machine learning with Spark. You might use Dremio to do some transformations with SQL. And you want them all to work together and bring that together at once. Well, you create a branch, you do all the work in it, you merge it when it's done. And so this is a familiar workflow for data engineers and data scientists, but now you can bring it to how you think about and work with data. Another piece that's something that we've heard from a lot of customers is the challenge with managing experimentation. So a lot of our customers maintain copies of data in sandbox environments to enable their data scientists to try out new ML models or new feature sets. Or they might create an environment for an analyst to test out new technologies, because you're always trying to evolve using the right tools to satisfy the new use case. Being able to do it in a risk-free environment is something that you get when you're managing data as code. So with Arctic, you create a new branch and you run an experiment in that branch, and that doesn't touch your production data. So production data is always available. The beauty is that now you can easily compare and reproduce results from each experiment. You just simply query the right branch, and you don't have to manage those expensive copies of your data. The key to this reproducibility is, as I've been talking all along, the familiar concepts from the Git world. And to support that, Arctic introduces an user experience that's very similar to GitHub or GitLab. You can browse tags and commits and branches. Branches and tags essentially are labeled commits, so you can think of them as point-in-time snapshots of your data lake. And you can easily refer to these in SQL from Spark or Dremio or other query engines. So if you tag a commit as an example of the state of your data on September 1st, 2022, you can easily build a dashboard showing you the state of the business on that date, and you can compare it to the state of the data when you're querying your data lake today. And that's easily supported using these Git concepts of branching and tags. And lastly, one of the key points that Kevin brought up that's a challenge with data lake management is observability. Well, being able to audit the history of what changes were made to data and metadata and by whom allows data consumers, whether they're analysts, engineers, scientists, to really trust that they're using the right set of data. With Arctic and managing data as code, you can browse the commit history of a table, and you can see all of the transactions that were done on a table or a branch. And this can be transactions regardless of what engine or tool was used to manipulate that data. This commit history is a really powerful tool for auditing what's been done to trust the data, but also just for governance reasons, for understanding who has accessed that data, what have they done to that data, and being able to make sure that the right people get the right set of data at the right time. These are just some of the examples where we're taking some of the DataOps principles to make data lake management easier, and we're enabling that through this new paradigm of managing data as code. Kevin, what do you think?
Anushka, great stuff. I thought you did a good job of explaining how this could really operate in a user environment. And if you think of the 4 pillars of DataOps, it's easier to orchestrate when you have data that you're handling like code. It's easier to test. It's easier to monitor. And it's certainly easier to handle through CI/CD the implementation and development of different pipelines. So I think there's some great open source and commercial tools out there that I encourage folks to learn about, because in my view, a key gating factor for the success of the data lake is very much data ops. And I think that data ops is an idea that's been out there for a while. Adoption is high. It needs to be higher. It needs to be a lot higher. And I think it will be with folks taking a hard look at the open lakehouse. Good stuff. What I wanted to do now is just talk about what good looks like for data leaders, analytics leaders within enterprises, if they're able to put some of these principles to work, the people in the process, and of course the technology, as Anushka was walking through. The benefits, there are really 3, in my view. One is higher productivity, looking at data engineers and their ability to handle this explosion on both sides. Right now, they're kind of caught in a vice between an explosion of the supply of data, volume, variety, velocity, and an explosion in demand for that data, users, use cases, applications, devices, and so forth. If you can improve the productivity of the data engineers that want to use something like an open data lakehouse in order to deliver that data, you can definitely deliver business results that are going to get the attention of the executives. Another is reducing risk. There are a lot of risks associated. We've talked about that, but reducing the number of data copies, improving the quality of data copies, and maintaining a single version of the truth has huge implications in terms of risk reduction from a compliance perspective and in terms of business results, analytics value that you can derive. And of course, the upside is, ideally, you're enabling data scientists, data analysts, data-driven applications, maybe they have embedded analytics to extract more value from data because they're able to, with higher confidence, look at a higher volume of faster moving, higher quality data. It helps support existing use cases more effectively, and it can help you support new potential use cases as well. So that's the vision to keep your eye on as you dig into the nitty-gritty of really enabling data ops in an open data lakehouse environment. Okay, so
Yes.
Anushka, why don't I get back to you? See what you think.
Yes, exactly. Thank you, Kevin. That is what we want to enable with DremioArctic. It is the service that is a managed Nessie service. So you're totally welcome to try our Project Nessie, which is open sourced. But Arctic on AWS, on cloud, lets you test out for free being able to manage your tables, optimize those tables, and the Git-like capabilities that let you manage data as code, really empowering data ops for your data lake platform. This is important as you think about a cost-effective way of managing your data lakehouse today and in the future as the data volumes and use cases evolve. It will work with multiple query engines and really help you future-proof your data architecture. Feel free to look at the website on the screen and you can get started with it. It's currently out in preview. Would love to have some feedback and as you try it out and get to use the best practices that we just learned about today. On that note, we're going to switch over to some Q&A. I want to thank you all for attending this webinar and giving us your attention. And let's take your questions.